We're asked to solve some simultaneous equations here. And it's not essential, but I'm just going to sketch what this would look like. In fact, the left-hand curve would be a circle centered at the origin. And the right-hand curve, if I was to rearrange it, it would be y equals 3x plus 4. And so it's going to have a gradient of 3, y-intercept of 4, and will look a bit like this. And when we're asked to solve these, well, although we're just asked to solve them algebraically, we can have this geometrical picture. We're being asked to find where they intersect. And at their respective points, they have the circle and the line have the same x values. So here they do, and the same y values, and as well as here. Okay, they're different for different points, but they're at the particular point, they have the same x values, which is essentially how we go about solving this equation. Because I can replace this y here by this 3x plus 4, because they're the same, take the same value at this point. Therefore, my first line would be x squared plus 3x plus 4 squared equals 34. I've chosen to replace y. It's just a little bit easier because then I've got no fractions involved. I could do x instead, but then I'd have to divide by 3. It's just going to be more awkward. So y is definitely the one to go with. And we can't use anything like, we can't be adding or subtracting the equations because these both have got, they're both being squared. So we can't cancel it out in that way. So we have to use this idea called substitution. But now I've got an equation in x, I just need to sort it out, solve it. So I can multiply out this double bracket, and this is going to give me 9x squared, and I'm going to get a 3x times 4, but then I'm going to double it, 24x plus 16 equals 34. Okay, do that a little bit more slowly. So what I've just done is done 3x times 3x, then I've done 3x times 4 to give me 12x. I've done it here as well, 12x, added them together, and then finally 4 times 4. So that's where all that came from. Bring it together, so it's going to be 10x squared plus 24x minus, now need to do 16 minus 34, that's going to be minus 18 equals 0. We always try to get the quadratic equal to 0 because that's, we've got methods for how to solve it. I'm going to try to factorize this, except first divide through by any common factors. There's a common factor of 2, so it's going to become 5x squared plus 12x minus 9 is equal to 0. If this is going to factorize, and I'm expecting it to, I'm going to get 5x and x here. Okay, there's another combination that's going to give me like nice whole numbers. And then I've got to try some things out. So maybe I try 3 and 3. That gives 9. Maybe I write it, like normally I say actually, write it below and then kind of do the cross multiplying. So I'm going to get 15x and I'm going to get 3x. So it's going to be possible to get 12x if I stick a minus there, which means I need to make this one minus 3 and this one plus 3. And you can see I'm going to multiply to give minus 9 and I'm going to add to give 12. If that hadn't worked, then I'd have to try 9 and 1 and then, sorry, 1 and 9 and then 9 and 1. Okay, and then I would have exhausted all possibilities. So that's going to give me x. This bracket is going to be 0, so x is going to be 3 over 5, or the second bracket is 0, so I'm going to get minus 3. Now I need to substitute it back in to get y, and I can put it back into either one. It makes sense to substitute it into this one here. It's just a little bit simpler. Y equals 3x plus 4. So when x equals 3 over 5, y will equal 3 times, that'd be 9 over 5 plus 4. 4 is equal to, if I put it over common denominator, actually let me do that. 9 over 5 plus 20 over 5, I'm going to get 29 over 5 is my answer. I'm not asked for coordinates here, so actually I'm just going to leave my answer like that. And then when x equals minus 3, y is going to equal minus 9 plus 4 is going to be minus 5. Sorted.